So this is Brian from Breaking Down Security. The class that we've got coming up is with Mr. Matt Miller. Of course, you can see him right here. He teaches at the University of Nebraska at Kearney, and we're just doing this intro video to kind of teach and tell everybody about what the class is going to be about. I know the classes start the 2nd of April, so maybe we can go through and discuss a little bit about what the syllabus is about. Maybe we get a little bona fides about who Mr. Matt is. So welcome, Matt. Not to the show, of course, but to our little advertisement here about what the class is going to be. So, what made you want to teach this class?
So, teaching assembly and doing reverse engineering is something that I get very excited about. It's what I do research in when I have time to do it. And so, you had mentioned that you thought people could benefit from doing some reverse engineering, and so I thought, well, what better way to do that to introduce assembly and then learn how to do reverse engineering of that code that you see and you can read.
Right. So what kind of skill level do we need to have to start the assembly training? And the assembly training class will be, of course, first, because it kind of adds and builds on to the reverse engineering, I would imagine.
Yeah. So I think the basic understanding is how to generally edit something in a Linux or Unix environment. So that's what I'll start with, and I'll try and point out some of the pointers, like my 45-second how do you use VI tutorial, which is, here's how you insert, here's how you do other things. And if people want to use, Nano, more power to them, or Emacs, they can torture themselves. But, as long as they can do that and use one of those systems, I think that'll probably be pretty easy to get into the class. And you've built a virtual machine for the class, and it has the tools that we need for it. And so as long as they can get that up and running, then they should be good for class.
Yep. I tested it in VMware. It should work in VirtualBox too. I'll probably create a version of that and put it up as well for VirtualBox. So if people want to use VirtualBox over VMware, that's entirely possible. So, so some of the prerequisites, of course, other than the VM and some knowledge of the Linux command line, this is all going to be pretty much on the Linux side. This is going to be strong Linux stuff, right? We're not going to do a lot of Windows stuff.
Yeah, I think so. Getting the basic concepts, it's a lot easier to get an environment set up so that you can do assembly, compiling, decompiling. All of that is really a lot easier to do inside of the Linux system, because they have a bunch of tools that are built on the command line.
Right.
And so, I put together a lot of different parts, so that they can write code in assembly, and they don't have to go and download Visual Studio or use some proprietary, assembler that you have. And then the other thing is that I use NASM, which is an assembler, and that one gives you the same type of output that Microsoft's or MASM produces. And so when you go into an editor like IDA or Binary Ninja, it's going to look the same. And so you're not going to be unfamiliar when you jump into a disassembler. It'll be very much familiar to you. All of the operations are similar. So that's kind of the logic behind doing that.
Excellent. So it does say Raspberry Pi is required. So in any specific type of Raspberry Pi that they should be getting?
It doesn't matter which one they have. They just came out with the new 3B, I think. So it's the same price as the 3, so that's the one I recommend. But for all my classes, we're using Raspberry Pi 2s or 3s, and they're working just fine, the old version. So
okay.
And it should work on any of the 2 also. I've used it before, so.
Right. And the need for the Raspberry Pi is for what?
So in the last session, we're going to be doing some ARM assembly, and so that's going to kind of contrast some of the things that you can do in x86 versus some of the things that you can do in ARM. Mm-hmm. And I think there's a lot of material on x86, and there's not a lot necessarily on ARM. Yet, if you look at where we're moving with mobile for cell phones and tablets, right, those are all running ARM. Windows is coming out with their new, ARM with x86 emulation. So I think ARM is going to be more of a focus in the future, just because of the savings that people get with the power and battery life.
Excellent. Okay. And the classes will start on, like I said, the 2nd of April. It will start on Monday nights at 8:30 p.m. Central Time. That's 6:30 p.m. Pacific. I don't like to figure out whether or not it's Pacific Daylight or Central Daylight or whatever, because not everybody does that. But so Central Time at 9:30 Eastern, and the time and the length of time of the class is going to be roughly what you say, about 90 minutes.
Yeah, I think that's about right. And we'll have time for questions. And I think it's beneficial to have something to do for that week, but you sometimes don't have time to do that, and so people might just want this for the content. So there'll be the homeworks, they'll be published,
Okay.
and so people can do them, after the class or during the class.
Excellent. Okay, so in the VM, you mentioned NASM, of course, and we're going to have GDB that is going to be used, which is the GNU debugger. In Tyler's class, which if you want to watch that one, it was a little bit more Windows, and it was a little bit more of like Ollie debug, which is probably one of the free versions of Windows debugger. There's one called Binary Ninja. Is that what is Binary Ninja going to be used for in the class?
So Binary Ninja is a disassembler, and it'll be predominantly used in our second class, but we can take binaries that we create and we can open them with Binary Ninja just to look at. So there's a relationship between your source code and the assembly or the binary code that gets generated. And so another part of this class is understanding, if you write something at a high level in C, what does that get broken down to on the assembly side?
Right.
And so there are a couple different disassemblers. Object dump is one, readelf is another one. So those are free on Linux, but
Okay.
they're just giving you sort of a static listing, whereas a disassembler like Binary Ninja is going to pull that thing apart and then let you programmatically manipulate that, so that if somebody generates some read write executable code that's self-modifying, right, you can go through and you can write scripts to go through and analyze that binary.
Right. Okay. So we've talked majority about the assembly class. So let's say I know everything about assembly. I named my firstborn XOR, and I don't want to do the assembly course, and I just want to do the reverse engineering training. What can they expect to see in that class if they just wanted to take that class?
If they want to take the reverse engineering.
Just the reverse engineering
Yeah.
course.
So in the reverse engineering, it's going to go over a lot of the different concepts of how do disassemblers work. What are different file formats? So, people will use different file formats for, there's a different file format for Windows and Linux and OS 10. So understanding a little bit about those, a little bit about the process of how do you take apart one of those and look at the different structures that are stored within it and learn, if I have a packer, how does that work? Right. So you have to understand how the binary works. Otherwise that packer might get past your defenses. And then looking a lot at the how do we take the high level concepts in C and how do those map down to the assembly. So this is going to be much more heavy on that type of mapping. So whether it be C or C++, or even the Windows API for standard things that malware are going to do, that's what's going to be taught inside of the reverse engineering course. So this will be much more heavy on challenges where part of the fun and the learning comes when you don't know what something does and then trying to figure out how that works. And that's the entire point of reverse engineering, is taking something that you have no idea how it works and figuring out what all the different parts are. Well, you have to understand those high level structures that a hacker is going to code in, or even just a programmer, right? So another, malware is where we're talking about it, but if you're given a binary that you don't have the source code for anymore and you want to modify that, then reverse engineering is where you go. And so there are a lot of other uses for it, but we're sort of capturing it in the fact that we want to reverse engineer malware at a static level. There's an entire separate level of figuring out what malware does by just running it, right? People will detonate malware in a virtual environment and see what kind of indicators come out, but malware can also do detection of virtual machines and not act the same way when you detonate it in a VM versus what it actually is going to do on somebody's box.
Right. Okay. So that all sounds really great, and I look forward to seeing that. So the question I have is, so the assembly class would be considered like a 201 level course, or is it like a 101 level course? I mean, how? And
So at UNK, it's a 300 level course, and then the reverse engineering is a sort of capstone 400 level course.
okay, so it's fairly advanced. It's fairly advanced. Okay, but
Yeah, we generally wait until they have a little bit more programming under the belt. When they come in, they may have never programmed in their life, but they think it's interesting. And so giving them a little bit of time and a lot of practice in programming, for example, in C, right? So they
right.
have that understanding about data structures, like what's a linked list? How do you build a linked list in C? So those are classes that are prereqs for the assembly class that I teach, and it's a lot about maturity, but also there, you might see a linked list in there, and just understanding how that works at a C level is a good thing.
Awesome. Okay.